Now let's look at some examples to help you to be familiar with the product rule and the quotient rule. So the first example, f of x equals x times cosine x. So this function f is the product of two functions. One is x, the other one is cosine x, right? So if you take the derivative, we can use the product rule. So the derivative of f equals, the first function is x, so the derivative of x times the second function plus the first function times the derivative of the second function. So let's do the calculation. X, take the derivative about x, which is equal to 1, right? Times cosine x plus x times, what is the derivative of cosine, which is negative sine. So if you simplify, it would be cosine x minus x times sine x. The next example, we have f of x equals sine x over cosine x. So obvious, this is the quotient. This is the quotient between sine x and cosine x. You can use the quotient rule. So the derivative of f equals, the bottom function is cosine, so it's the cosine x squared. Okay, so here are some conventions. We often write a cosine square of x. That means cosine x, then the whole thing square. Okay. Then the numerator is the derivative of the sine, the top function, times the bottom function, minus the derivative and the top function times the derivative of the bottom function. So this would be cosine x times cosine x minus sine x times negative sine x over cosine square. So this would be cosine square, right, plus sine square divided by cosine square. So here is a very famous identity, trig identity. Cosine square plus sine square equals 1. So it's 1 over cosine square. Okay, if we want to write as the secant, so this would be the secant square. So here is the remark for this problem. This example tells you some the derivative of trig functions. We notice that sine x over cosine x equals tangent x. So the derivative of the tangent x is actually equal to secant square. So similarly, you can see the derivative of the cotangent x. You can try cotangent is cosine over sine, which is equal to negative cosecant x squared. Okay. So now let's look at another one. F of x equals 1 over cosine x. So this is also the quotient between two functions. The top function is 1, the bottom function is cosine x. So if you take the derivative, it would be, the denominator is cosine square, right? The numerator is the derivative of the top function times cosine x minus 1 times the derivative of cosine function, bottom function. So this would be cosine square, and 1 take the derivative equals 0, so this would be 0, right? 0 times cosine equals 0. 0 minus 1 times, what is cosine? The derivative of cosine. Derivative of cosine is sine, so negative sine, so it's the negative sine. Then you will have sine x over cosine square. Okay, let's rewrite it. Of course, if this is the problem, you can stop here, but we want to derive some formulas, okay? So let's rewrite it. This one can be written as 1 over cosine x times sine x over cosine x, right? So what's that? 1 over cosine, which is the secant x, and this times the tangent x. Okay, so let's look at the remark for this problem. We notice that 1 over cosine x equals secant x. So the derivative of the secant is actually secant x times tangent x. Okay. Similarly, you can look at what is the derivative of cosecant, which is equal to negative cosecant x times cotangent x. Okay, so let's summarize what we have for the derivative of the trig functions. So we know that the derivative of sine equals cosine, right? The derivative of cosine equals negative sine. The derivative of tangent equals secant square. The derivative of cotangent equals negative cosecant square. The derivative of secant equals secant times tangent. The derivative of cosecant equals negative cosecant x times cotangent x. Okay, so here these formulas, these 1, 2, 3, 4, 4. These 4 are very important. You need to memorize it. You may need it for the future. So let's look at more example. Another example. F of x equals x squared times tangent x. Okay, so this is the product of two functions. One function is x squared, the other function is tangent x. So the derivative of f equals the derivative of the first function times the second function plus x squared times the derivative of the second function. So this would be 2x times tangent x plus x squared times what? What is the derivative of this tangent, which is the secant square? Right? You can use this formula directly.